Hi 111. In this last video we're going to finish off our graphing calculator activity. We're going to start with number 6 because we had a little bit of a glitch last time. We had a frozen screen in our last video. So let's continue with number 6. In number 6 it asks us to graph the equation y equals x squared plus 5x plus 4 in the calculator. So let's go ahead and turn on our calculators. Mine is on already. Let's go to the y equals menu here and we'll enter x squared plus 5x plus 4. Okay, and let's go ahead and just hit graph and see what we get. Lovely, we get a parabola shape as expected because we see that x squared and we don't have a y squared term. And so now what we're asked to do is use the trace feature to estimate the lowest point on this graph. So let's hit trace. The lowest point on the graph is going to be here at the vertex because this is an opening up parabola. Now this gets a little bit tricky as you try to do this just by eyeballing it. We're looking for the lowest place on the graph or the point that has the smallest y value. That looks like it, but if I arrow over a little bit, ooh, that's actually a little bit lower, isn't it? Or is that a little higher? Ooh, that's negative 2.24. Actually, that one's the lowest one I can see on my calculator. Yours might be slightly different because you may have different window settings, or you may have zoomed in differently or something, but I'm in a 10 by 10 viewing window now, and that's the smallest I can get. Okay? That's the minimum point on the graph that I can see. That's not exact, however, because I've just tried eyeballing it. We could use the second calc feature here, calc above the trace button. So hit second calc, and I can go to the minimum option, number 3. Now when it asks this left bound, right bound question, it's just asking for a little interval about where it wants you where you want the calculator to look for a minimum. So just make sure you're to the left side of where you think the minimum is and hit enter. Notice it gives you a little arrow about where it's going to start looking for a minimum. It's going to say I'm going to start looking here and I'm going to stop looking wherever you tell me on the right side of where the minimum is, you think. About there looks good. In between those two arrows is where it's going to look for a smallest value for the function. When it says guess, just hit enter. Okay, now here's an interesting thing. Because of how the zoom in level I'm at right now, the standard 10 by 10 viewing window, sometimes you get this like repeating 9 kind of thing going on here. If I zoomed in a little more and repeated the process, this would actually probably exactly be negative 2.5. Let's see, let's try doing that. Zoom in. We'll try zooming in right, and again zoom in. Remember, you can put the cursor wherever you want to zoom in. Okay, there's that little bit of our parabola there. Now let's try doing the second minimum again. Okay, so second calc, minimum. Let's get to the left side. Enter. Let's get to the right side. By the way, if you just hold the right cursor, it'll sort of run along the graph and guess whatever. Aha! See, because we were able to zoom in, it got a better look at where the minimum might occur, and it's able to give us that actual ordered pair, right? So for us, the ordered pair for our minimum is going to be at negative 2.5, comma, negative 2.25. Okay, and that's the ordered pair. Okay, if we were to do this algebraically, remember what that would mean is that we have to find the ordered pair of the vertex, right? And the ordered pair of the vertex looks something like this: negative b over 2a. And then we have to get the y value corresponding to that x value, right? And I think in 95 we used function notation, but we haven't gotten into chapter 2 yet, right? So I'll sort of just leave this blank here for a second. We'll figure out what that is in a moment, okay? But algebraically, I see that the x coordinate is going to be, let's see, a, b, and c, remember, come from the coefficients of the terms in the expression for the quadratic right here, right? So I see that a is equal to 1, and I see b is equal to 5, and I see c is equal to 4. So when I plug stuff in, I get negative 5 over 2 times 1. But this is just negative 2.5, and that's exactly what we had right here, remember? Yep, that matches. So now to figure out the corresponding y value, all I have to do is plug in negative 2.5 into the equation, right? And again, this is a little bit tedious because what you have to do is you have to say, okay, I'm going to put negative 2.5, I'm going to square it, plus 5 times negative 2.5 plus 4. Right? And you can go ahead and do that using your handy dandy calculator over here. And what you're going to get is the y value that's actually produced right here, right, from our graph before. Okay, so let's skip over here to part C, right? Let's use a table of values on the calculator to complete the following. Okay, so table is above your graph button right here, so we can do second graph. And here's our table, and what it's giving us right here are ordered pairs that live on the graph we just had for a second. See y1 right there? That y1 is referencing the equation you have stored right here in y1. Okay, so what this means is that if you plug in 0 for x, it's going to give you 4 for y, and that makes sense according to our equation. If you plug in 1, it's going to give you 10, 2, 18, so it's giving you the corresponding y values for whatever x you have. Now, it wants us to say, what is y when x is negative 1.23? Well, that's not on any of, I don't see that in any of my x values here. The reason is because your x values are set as integers in this case, right? So let's change that. See table set above window, right? Table set above window, I'm going to go to that key. Again, if I go too fast, remember you can pause the video, try to find your buttons, right, or sort of scan back in the video. There's a couple options here. Independent and dependent mean x variable and y variable, right? And we'll talk about that with functions more in chapter 2. But the best thing to do when you want to figure out what the y value is for a very specific x is to change the independent variable from auto to ask. Okay, so highlight it and hit enter. And now when we go back to our table, again, second graph, right, will go take us back to table. It's just waiting for us to tell it what x value we want. So go ahead and plug in negative 1.23, hit enter, and now it gives us, poof, the corresponding y value, right? So for part C, I see that we will get the ordered pair negative 1.23, comma, negative 0.6371. Okay, that's for the first one. For the next one, when x is 25, I can just plug in over here on my calculator 25. And I'll say, what's y? 754. Okay? So that table, when you just have it set to ask, is pretty nice because it quickly figures out corresponding y values for whatever x value you want. All right, so now let's move on to the last page. So let's graph both of the above equations. When they say both the above equations, that means equations from number 5 and number 6, right? 5 and 6, this line and this parabola. So let's go back to y equals for a second. I already have the parabola. Let's go ahead and input the line 2x plus 6. Okay, and if I hit graph right now, remember I'm in that zoomed in level where I was looking at the vertex of the parabola, so I'm not going to see a nice pretty picture. Let's go to zoom standard. So zoom standard is zoom 6. And there's the parabola. It's graphing it first because that's y1. There's the line. It's graphing that second because that's y2. Okay, now let's go down to number 7 and see what it wants us to do. So let's graph both the above equations on the same set of axes and use the trace function to estimate the coordinates of the 2 points where the graphs cross. Okay, this is where they intersect. So let's hit trace, and we can move along the parabola here to get an idea about, ooh, it looks like it's right about there, but again, this is really like hand wavy, right? We can't really see where the intersect is. By the way, you're currently on the parabola, which is why it says y1 up here. If you hit up or down on your calculator, it'll toggle or jump to the other graph, y2, right? And you can now move along that one. Okay? So, sorry about that. Let's see. So let's try to use the intersect option, second, calc. Intersect is number 5 to try to find where these two things intersect. Unlike minimum or 0, you don't have to give it sort of an interval where to look in this case. You just want to try to be right on top of the intersection. So let's find this left intersection right here. Okay, so first curve, it looks like it's on top of the intersection. Second curve, let's see, right about there, maybe? Good, enter, guess, whatever. There's the intersection, okay? And we have to just kind of, we can just drop that to like 2 decimal places or something like that. Okay, so for number 7, the first ordered pair we get is negative 3.56, comma, negative 1.12. Okay, and then you can repeat the process again with this second intersection point up here, right? You can do second, calc, intersect is number 5. And now we want to go over and do this for the second point, right? Arrow over. Looks like as close as I can get. Enter. And that looks good enough. Enter. Again, you need to be close, but not like obsessively close, right? So there's the second intersection. 0.562 maybe, and 7.12. That's good enough. Excellent. Let's make our way to number 8. Let's graph a circle. Okay, so in number 8, we want to take this equation of a circle, x minus 4 squared plus y squared equals 25, and graph it on our calculator. Note you can't graph equations like this without getting them y equals first, right? Okay, so to solve this thing for y, which is right over here, first let's move this big ugly term of x stuff over. I'm going to subtract that from both sides. Okay, when I do that, I get y squared equals 25 minus x minus 4 squared. And now to get y all by itself, I have to square root both sides. Okay, so y is equal to, this is using the square root property, by the way. Y equals, I get plus or minus square root 25 minus x minus 4 squared. Don't forget the radical right here can't move across this subtraction right here. It can't attack the 25 and this squared thing individually, right? So you can't say this is 5 minus x minus 4. That doesn't work, okay? The radical can't move across this subtraction right here. I'm sorry about all the emails. Let's see. So now what I want to do is try to graph both of these equations because there's two of them, right? So let's go to y equals here. Let's clear out everything. So I get, first of all, square root 25 minus, make sure you use parentheses for grouping symbols, x minus 4 squared. Close the parenthesis for the radical. And now I go down and do the same exact thing, negative, not minus, square root 25 minus grouping symbols, x minus 4 squared. Close the radical parentheses, hit graph. And again, I already prepped you on the idea that if you were to graph a circle on your calculator, it's going to look like a football because you have this like inequality of the tick marks on the horizontal and vertical axes. If you hit zoom square right here, number 5, it's going to square up the axes for you and make it look more like a circle. Now the reason I don't touch right here is because your calculator can't graph vertical stuff. It doesn't like that, right? So it kind of just leaves a little gap. Okay. I'll hold off on doing number 9 for the next video because that one's kind of different, right? But at the very least, this gives you all of the basics for using your graphing calculator.